Welcome to Math Mini Lessons. In this video, we're going to start breaking down the 2024 third grade math exam. And a big shout out to Amber Charter Schools, an awesome charter school network here in New York City. So in this video, we're going to work on multiple choice questions. There are 30 multiple choice questions that we're going to go over. 25 happen on day 1, and 5 happen on day 2. And in the next video, we'll look at the constructive response questions. All right, let's look at the first two problems. And the answers for number 1 and 2, if you've already done them, are A and B. So check your answers. And if you have these two answers, great, move on to the next chapter. If not, stay right here. All right, let's start by going over question 1. There are 40 stickers on a sheet of paper. The stickers are in rows with 8 stickers in each row. Which expression represents how to find the number of rows of stickers on the page? Okay, so when I'm thinking about this, I know I have 40 stickers, and I know that it's set into different rows, and there are 8 in one row, and then there's another 8 in another row, and then there's another 8 in another row. And I know that altogether, I just need to figure out how many rows would be there. And so all I know I'm doing is I'm equally sharing. I know that I'm thinking of division. So I am taking these 40 stickers and I can divide by 8 to figure out how many rows I have. Now, they're not asking us to actually solve this. They're just asking us which expression can be used, and that would be A, because I have an equal share. I know that it can't be subtraction because I can't just subtract one group of 8 stickers. That doesn't make sense. I have 32 rows, and not when I know that there's the same number in each row. And I can't multiply it because that would just make 40 and another 40 and another 40. I don't have more stickers. I'm sharing the stickers that are there. And I can't just add 8 because, again, I just have 40 stickers. And I'm trying to figure out how they're being shared out together. So division makes sense. Let's look at number 2. And number 2 is a rounding problem. And I really like rounding problems a lot. So in this one, they're asking a number is rounded to the nearest 10. The result is 300. Which number could it be? So here's what I'll tell you about rounding. Each of these numbers is between 2 other numbers. And we're trying to figure out, I'm going to go by tens. We're trying to figure out if I rounded it, which one is the closest it's by. So for example, with 289, I'm between 280 and 290. So how do I know which one is closer? Well, I know that 289 is very close to 290. Much closer to 290 than it is to 280. But we were looking for the one that is closest to 300, so I know it cannot be A. Another way I can do this is I can look at the number 289, and I know I'm rounding to the nearest tens place. So I look at the digit in the tens place, and I'm going to look at the number right behind it, its buddy, right to its right. And then I'm going to look to see, am I going up? Am I rounding to the number, the higher 10 or the lower 10? So I sometimes say this rhyme, if it's 0 to 4, I'm going to round down to the floor. I'm going to go to the lower number. If it's more than 5, I go up to the sky. So that's kind of like the little rhyme I always say to myself to figure out, am I rounding up or down? So let's try it with this next one. And here I have 296. So here's my 9. My buddy is a 6. So it's more than 5. So that means I'm going to round up to 300, which is what we want. Let's try the other ones just to see what we have here. In C, I do have a 0, but look at his buddy. His buddy is an 8, which means I'm going to round up to 310. So that's not what we wanted. And in D, I have a 1. Its buddy is a 5. So it's more than 5, up to the sky. So I'm going to round up to 220. So B is the correct answer. All right, hit pause and jot these two down into your notes. Let's look at numbers 3 and 4, and the answers for 3 is D and 4 is B. So check off and see if you have the same answer. If you do, Awesome. You can move on to the next chapter or stay right here and see how I actually worked out the problem. Maybe I have another way that can really help. And if you didn't get the right answer and you want to see how I break it down, stay right here. All right, with the first one, Mr. Green buys 4 packs of cups. Each pack has 8 cups. Which expression can be used to find the number of cups he buys? So let's think about it visually. He buys 4 packs. And each pack has 8. So I could represent this as 4 groups of 8. This could be 8 plus 8 plus 8 plus 8. Or I can just say 8 times 4, 4 times 8. And that's why D works. Notice there is an 8 plus 4, but that's not what we're looking for. I don't have 4 equal 8s, groups of 8 there. And again, I'm not dividing because I'm not sharing the 8 packets, the 8 cups into each one. I know each pack has 8. The subtraction doesn't work either because I'm not subtracting the cups from the packages. That doesn't make sense. All right, let's look at the next one. And this one is a number line. Number lines can be really tricky for a lot of kids, mostly because it's a 0. And because a lot of times we don't know what fraction we're really looking for. So I'm going to show you a way I actually work this out. So take a look. First thing I'm going to do is I'm going to count after the 0 how many pieces. Because my goal is to figure out what point P is on the number line. So after 0, I have 1, 2, 3, 4, 5, 6. So there are 6 pieces here. So 6 out of 6, which is the same as 1. And I'm going to use that 6 as my denominator for all my pieces here. And now look what that does. That gives me something here where I can see the fractional parts for all the dashes, and including the one I want, which is P, which is 4, 6, or B. So this one really, really works well. But again, notice that I go after the 0 when I start counting by ones. All right, hit pause and jot this down into your notes. Okay, let's look at the answers for 5 and 6. For 5, you have D, and for 6, you have A. Let's start going over them. In 5, we want to know which expression is equivalent to 5 times 7. So I know that 5 times 7 is 35. I will say on this 3rd grade test, super helpful if you know your times tables. If you're fluent in your times tables, it will really help you on this test because then you don't have to calculate and skip count so much. So I'm going to go through this assuming that I know all my times tables. So I'm looking to see which one of these, A, B, C, or D, has the same value as 35. And I'm going to use my order of operations. So starting with A, I'm going to start with my parentheses first. And I have 5 plus 4 plus 7 in parentheses is 7. And that equals 12. Well, 12 does not equal 35. In B, I have 5 times 4 times 3 is 12. Well, 5 times 12 is 60. That is not equal to 35. So notice in here, I'm always doing the parentheses first. So in C, I have 2 sets of parentheses. I have 5 plus 3, which is 8, and 5 plus 4, which is 9. So I have 8 times 9, which is 72. That is also not equal to 35. And the last one, 5 times 3 is 15, and 5 times 4 is 20. So here I have 15 plus 20, which is 35. And that's why D is the correct answer. So again, equivalent, you just have to actually simplify the expression and use your order of operations. Let's look at the next one, number 6. A student draws a rectangle on a sheet of paper. He labels 2 of the sides 1 unit and the other side 2 units. Okay. What is the area of the rectangle? Well, let's just draw the rectangle. And here's 1 unit here and 2 units up here. So what is the area? Well, if I think about this, is how many square units do I have? So I have 1 side here, and on the top I have 2, which tells me I have 2 rows of 1. So my area is the number of these squares. I have 1, 2. My area is 2 square units. So that gives me A. And some kids also just know to multiply the length and width, and so they probably just did 1 times 2, which gave them 2 square units. Both work, but I really like the visual. All right, hit pause, jot this down into your notes, and we'll go to the next problem. All right, let's look at numbers 7 and 8. For 7, the answer is A, and for 8, the answer is D. So starting off with A, which number makes the equation true? So I need to know what this number is in here. So 48 divided by something makes 8. So if we know our fact family, and I'm going to use my triangle for this, 48, and I have 8, and I have to know what the other number is. So I know that these two numbers, 48 and 8, are being multiplied together. So let me get my little pointer out. So I know I'm multiplying these two numbers together to get 48. I also know that I could think of these as division. 48 divided by 8 gives me this number, or 48 divided by this number gives me 8. So what really helps with this is a fact family, already knowing my multiplication division. So I know that 48 divided by 8, the only way, 8 times what number? Only 6 will give me 48. Again, it really helps when you know your multiplication tables. If not, then you'd have to do your division to get 6. So that's the tough part about this, is that you just have to know your fact families to help. Some kids might go and start skip counting by 8. So it might go 8, 16, 24. And they might do this until they get to 48 and then just count how many 8s it took. And it took 6 8s. So that's another way you could do it. The challenge there is that you have to make sure you count correctly so that you don't make an error. All right, let's go to number 8. A librarian has 9 boxes of books. Each box has 8 books. Which expression represents how to find the total number of books? All right, so again, this is really nice to draw. So pretend these are 9 boxes. Each one has 8. So you could think about this as repeated multiplications, where you're just adding 8 plus 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 8. You could do that, but you notice that none of these has that. Or you can have a whole bunch of 9s, 9 groups of 8. That doesn't help either. But either way, you're noticing that you have groupings. So 9 groups of 8 when it's the same number is the same as 9 times 8. So I would have that one. So you have repeated addition, so I can use multiplication there. All right, hit pause and jot this down into your notes. Let's start the reveal for 9 and 10. For 9, you have C, and for 10, you have D. So as always, move forward if you have those two answers. If not, stay right here. We'll start with the first one, which has an irregular polygon, meaning it's not like a regular quadrilateral that we know the area of. But we have this 6-sided shape and we don't know how to find the area for this one. So what we're going to do to find the total area is we're going to decompose it. That means you're going to break it into rectangles. We're going to decompose it, break it into rectangles, because we know how to find the area. We can do this in 2 different ways. We can either choose to cut it here and have 2 pieces. Or you can cut it here and have 2 pieces. Really doesn't matter, because when you add the area of both pieces, you're going to get the same total area. So I'm going to decide to just cut this way. And because this will make it easier, I can see the pieces that I want. Here for this rectangle, I have a 3 by 9. So this is part A, and the area for A is 3 times 9, or 27 square feet. For B, from here to here is 4, and from here to here is 6. So I'm going to have a 4 by 6, which gives me 24 square feet. And to find the total, I'm just going to add those together. I don't know why I wrote 3 there for a minute. And then I get 51 as my final answer. So I have 51 square feet. Now, if you had done it the other way around, and let's just play with this idea for a second. So I'm going to just erase this for 1 second. So let's say you cut it the other way here. Well, the challenge here is that if I had cut here, at least I know this part is 3, but I have to know this little part here, from here to here. And that means I would have to do a little bit more thinking. I know from here to here is 6. So if this is 6, then the rest of it has to be 3 to make 9. So that would be the only thinking part. So let's just pretend we did that. We had 3 times 3 to get 9. And then on the other side, we have 6 times, what is this long part going to be? So again, from here to here is 4, and 4 plus 3. How do I know 3? Because that part is 3. So I would get 6 times altogether 7. Which would give me 42, and when I add those together, I would also get 51. So you see, it really doesn't matter which way you decide to cut the irregular polygon, as long as you are finding the correct area. The challenge sometimes is if you cut one of the sides, you have to use its opposites to figure out the other pieces. So just so my thinking worked there. All right, let's jump into the next one. I kind of like that one, so I'm going to leave that one there. With the next one, we have a librarian has 2 boxes. The first box has 136 books. The second box has 58 fewer books than the first. And what is the total number? And I'm going to give you a secret. The first time I did this, I was so wrong because I didn't pay attention to the total number. But we'll start with what's in the first box, which is 136. And we know the second box has 58 fewer, so I'm going to do 136 minus 58. So 136 minus 58. I'm going to start from the left. I can do 1 minus 0, but I can't do 3 minus 5. So I'm going to borrow. And now I can do 13 minus 5, but I can't do 6 minus 8. I'm going to borrow again, and I have 16. Now I can subtract. 16 minus 8 is 8. 12 minus 5 is 7. So this second box has 78 books. So the first time I had read this, I thought, how many more boxes does the other one have? Which is really a silly question in my head because I just figured that out. But this one's asking how many total boxes. So I'm going to do 136 plus 78. The first time I did this, I did minus 78. My brain just wasn't thinking. I wasn't reading carefully enough. But now I can add. 6 plus 4 is 14. 4 plus 7 is 11. And 1 plus 1 is 2. 214. Hit pause and jot this down into your notes. All right, let's look at these 3 answers, 11, 12, and 13. All right, here we go. Let's do the reveals. B, B, and D. Again, if you have any of these wrong, let's stay on so you can watch. If not, keep moving forward. We'll start with the first set, number 11. Mika has 11 gumballs. He gives all of them to his 7 friends. Each friend gets the same number of gumballs. Which expression can be used? So this is an equal share, that's important. Which expression can be used to find the same number of gumballs Mika gives each friend? So again, he's starting off with 35. He gives all 7 the same amount, so equal share to 7 people. So I know this has to be 35 divided by 7. That's the only way we can figure out how many gumballs he gave everybody, which would be 5. Let's look at the other ones. Which fraction is equivalent to 3? So I'm going to start by just eliminating the ones we know off the bat. I know that 1 cannot be the answer because that is less than 1. 1/3 is less than 3. 1/3 is less than 1, so it can't be equal to 3. And then we know that C I can get rid of because 3 over 3 is equal to 1. So I can eliminate those two off the bat, which leaves me with 3 over 1 and 6 over 3. So I can rewrite these fractions as division problems to figure out what they're equal to. So 3 divided by 1 is equal to 3, which is B. 6 divided by 3 is equal to 2. So I can cross that out. So that's how we can figure that one out. And let's look at 13. A teacher covers a wall with 100 square pictures. So that's important that they're square pictures. So automatically I'm thinking area because I have square units here. The pictures are the same size and the wall covers completely any gaps or overlaps. Each picture has a side length of 1 foot. So if I'm thinking about each picture, 1 by 1 foot. So each area is 1 square foot. So if I know that, what is the total area? Well, if I have 100 of these squares, the total area is going to be 100 square feet. Okay, because that would be 1. So if I have 100 of them, that would be 1 times 100. So 100 square feet. So these problems they're really trying to guess like how well you understand certain concepts. So the first one, just really asking like, do you understand anytime that you're equally sharing something? That is division. Can you recognize fractions, like if I have which fractions make 1, which fractions are less than 1, and which fractions are more than 1? And finally, do you have a concept of what area is with square feet? All right, so let's hit pause so you can jot this down into your notes if you had anything to correct, and then we'll move on to the next set of problems. All right, 14 and 15, the answers are B and D. We'll start with the first one. We want to know which rectangle is divided into 4 equal parts. So automatically, we can see the ones that are not equal, A and D, where we have pieces that are definitely, this piece is not the same size as this piece. And the same thing here and here. So they both, I can't say that this is 1/4 and this is 1/4. That's not equal. Clearly B shows me 4 equal pieces. A is deceptively, it's so deceptive because you don't have enough information to be sure, but I can definitely see with B that all 4 of these pieces are equal to each other to make the whole. Let's look at 15, and it's a pattern problem. They want to know which number pattern uses the rule plus 3. So in other words, I'm looking at the numbers and I'm just adding 3 to them each time. So if I started with 2, if I added 3, I should get 5. And boop, that's not what happened here. I ended up getting 6. So nope. So I'm going to look at the next ones, like if I started with 3, 3, and 4. So 3 plus 3 is 6. Plus 3 is 9, plus 3 is 12. And I'm looking, I have 3, and they're doing plus 3 is 7. Nope. And let's look at the next one. 3 plus 3 is 9. Nope. That's not how we do an adding problem. So let's try the next one with 4. So 4 plus 3 would be 7. Plus 3 would be 10. And plus 3 would be 13. And what do I have here? 4, 7, 10, and 13. So yeah, that matches our work. All right, hit pause and jot this into your notes. And remember, anytime it's a pattern problem, you can just try the pattern yourself and see if it matches what you're given. All right, let's look at question 16. And for this one, the answer is B. This is a trickier question, and it's because of the something in the reading. So I'm going to read it carefully with you. Greg walked 1 mile from his home to the store. After walking 2/6 of a mile, he stopped to smell a flower. So we know that happens there. And then he walks another 3/6. Matter of fact, I'm going to put another in another color so we have it in there. He walks another 3/6 mile and he stops to tie his shoe. Which number line correctly shows the location where Greg smelled the flower and then he tied his shoe? So thinking about this, if I was telling a story, he walks a mile, and so this is 0, this is 1. He stops at 2/6 to smell the flower, and then after another 3/6, so he walks another 3/6. So when he's at 5/6, he ties his shoes. That's supposed to be a shoe. Not too bad. Okay, so these are the two numbers we're looking for. We're looking for the 2-6 with a flower and the 5-6 with a shoe. Okay, so we have it. So now we can dig deeper into this problem. And just like before, in order to get the fractional pieces, I'm going to start after the 0 and start counting 1, 2, 3, 4, 5, and then 6 over 6. So where the 1 is, I have put 6 over 6 because that's 1. So I write the fraction as 1 with 6 pieces. And now I put my fractions there. Now I can look to see, like, are the two things true? So 1 is at 1/6, so I already know this is wrong. Both of these are wrong. Those aren't the numbers I'm looking for. So I'll go to B. 1, 2, 3, 4, 5, 6 over 6. I do the same thing. All right, so the flower is at 2-6, so that's right. And then the shoe is at 5-6. So that's why, which is the second number we wanted. So B is correct. So where a lot of kids get this wrong is because they start looking for 2-6. They see 2-6 and they see 3-6. And those are the two numbers they look for. But that's where you have to make sure you're reading carefully and not just glancing with your eyes. Sometimes our eyes move so fast. We have to stop and slow down our thinking to make sure. Like, even I did this wrong the first time because I forgot. I just skipped over another 3-6. But there you go. That's how you have the answer for this one. If you had gone with the other ones, you would have different fractional pieces. So I think for C, you would have had 8s. So you would have 5/8 and 2/8, which would have been wrong. And then for D, it was also 8s. So you had 4/8 and 1/8 with all, which was also wrong. All right, hit pause and jot this down into your notes. Let's unveil 17 and 18. There you go, C and B. All right, for 17, how many square units are needed to find an area with 56 square units? So again, they just want to see you understand what area is. So if the area is equal to 56 square units, how many, this is a silly question, how many square units would you need? 56 of them. They just want to make sure you have that understanding of what area is and that you have 56 squares, that you're starting to think about that visually. Let's look at 18. Which expression is equivalent to 5 times 4? So we know that 5 times 4 is equal to 20. So I'm going to use order of operations to figure out which one of these is equal to 20. So I'm going to do what's in parentheses first. So with A, 5 plus 2 is 7, and 7. So this is the same as 7 times 7, which is 49. That is not equal to 20. All right, 5 times 2 and 5 times 2, that's 10. So this is 10 plus 10, which is equal to 20. So that's why B is the correct answer. I tend to just check all of them just to make sure. I know a lot of times during a time test, you kind of get the answer and you keep moving, but I just want to show you the other ones just in case you chose them. So 7 plus 7, which is 14, and 10 times 10. So this was probably the one that most, if kids got it wrong, is because they didn't pay attention to this little part in here. At times, the times between them. All right, hit pause and jot this down into your notes. Let's unveil 19 and 20. So here we go, check and see what you got. And starting off with 19, you have 4 digits. You want to write a 4-digit number that has the digit 8 in the hundredths place. So I'm going to use all 4 of these numbers here, but I already used the 8. So somehow I have to use the 4, the 7, and the 2 to make the rest of the number. Now, the only ones that have an 8 in the hundredths place are B and D. And so this was really tricky at first. And I know a lot of kids would have, they just saw B and were like, well, there's an 8 in the hundredths place. I can keep it moving. However, I have a 4 in that number and I have a 2, but where's that 7? And that's what makes be wrong that there's a 5 here. It didn't use all 3 of these numbers. So, haha, if you just look for the 8 in the hundreds place, that's where you made an error. For D, you have the 8 in the hundreds place, and you have the 2, the 4, and the 7. So this was just checking about how closely we pay attention. All right, let's check the next one. A store has 8 fish tanks. Each fish tank has 40 liters of water. What is the total amount of fish tanks? So I'm not equally sharing here. Instead, I just have many with the same amount. So here are the 8 fish tanks. And each one has 40 gallons of water. So I could represent this as 40 times 8, which is 320. Now, how did I get that number so fast? Well, I know that 4 times 8 is 32. And so 40 times 8 is 320. This is 10 times bigger. All right, hit pause and jot this down into your notes. Let's look at 21 and 22. D and D. So let's start with 21 first. In which model the fraction of the whole shaded to, let me reread that. In which model is the fraction of the whole shaded to represent 3/8? So that's what I'm looking for. So I'm looking at my pieces here. I have 1, 2, 3, 4 out of 8 pieces. That's 4/8. Cross out A. 1, 2, 3, 4, 5 shaded pieces out of 8. So crossing out C. Same thing with B, because I want the shaded pieces, not the unshaded. So I can see some kids picking either B or C just because they're looking at the white parts and not the shaded parts. And in D, I have 3 shaded pieces out of 8. So D is the correct answer. A lot of these is not even, some of these aren't even just the math thinking, it's just being careful. Honestly, it's just being careful of our work. All right, let's look at this next one. Which fraction is less than 1/4? So I know that I could automatically get rid of A and B because 2/4 is bigger than 1/4, and 4/4 is definitely bigger than 1/4. Because if I'm thinking about pieces here, here's 1/4, so 2/4 is more than that. Here's 4/4, that's way bigger. So this automatically I can get rid of A and B. So now I'm stuck between 1/3 and 1/6. So I want you to think for a minute and think if you had to divide when you're sharing something with other people. The more people you share with, the smaller the pieces get, which is why 1/6 is smaller. So if I had, again, the same piece here, and now I'm sharing it with 6 people, my piece is going to be smaller than if I just shared it with 4. Okay, so the more people, the more equal pieces, the smaller it gets. So the bigger the denominator, the smaller the piece, when my numerators are the same. Now, if I just shared it with 3 people, my piece would be bigger. So the smaller the denominator, when my numerators are the same, the bigger my pieces, which is why, again, D is the correct answer. Hit pause and make any corrections in your work. Let's look at 23 and 24. The answers are C and D. Check them over with your work. All right, let's start by going over 23. And here we're looking for the one that cannot. Which expression cannot be used to find the area? So that means 3 of them will find the area. The other one cannot be used. So being that this is a rectangle, we know that usually we can find the area by just multiplying the length and the width. So I could just go, well, I have 5 rows of 7. So area is equal to 5 times 7, which gives me 35 square units. That's one way I can find the area. So that's D. That is a way to find it. I could also just count all the little squares to get to 35, but that's not an option here. So what other ways can I see area? Well, if I know I have 5 groups of 7, I could see it as literally 5 groups of 7, where I'm just adding 7 5 times. And that's exactly what we have here for B. Or I could see it the other way as 7 groups of 5 going down. So I can have 5 plus 5 plus 5 plus 5 plus 5. So that can also work. So that is A. That's another way of finding the area. All of these ways will give me 35. But the last one, 5 times 7 times 5 times 7, will not give me the area. This part would if this is all it was. But once I multiply it by another number that's bigger than 1, it gets bigger. So yeah, the answer is A. This will not find the area. So always think of that. It can either be adding up all the little squares together, counting them, finding addition problems, or even multiplication. Let's look at the next one, 24. A worker has 3 bags of pebbles in his garden. The mass of each bag is 9 kilometers. What is the total mass? So I'm just imagining I have 3 bags. They all have 9 inside. So the total mass, I could just add them together if I wanted to. That would get 27, or you can just do 9 times 3 to get 27, which is D. All right, let's go to the next one in a moment. Number 25, the answer for this one is B, and it's just a fact family one. What number multiplied by 8 equals 48? So I know that some number times 8 equals 48. There are different ways to think about this. For some of us, it literally just is our fact families. Like, you know that 48 can be made if I did 8 times 6. So some of you just know the fact family for this. Some of you might have also thought you could also just divide. 48 divided by 8 gives us 6. Again, is fact family. But if you weren't sure, like if you don't know your multiplication tables, you could have just kept counting by 8. And I see a lot of kids honestly do this, where they just make 8 circles. And this is for kids who just don't know their fact families. And I've seen them literally just start adding numbers in there, and they might think, well, let's start with an easy one like 5. Like if I had 5 in all of them, because I skip counting by 5s is easy, I would have 5, 10, 15, 5, 10, 15, 20, 25, 30, 35, 40. So 40 is really close. 41, 42, 43, 44, 45, 46, 47, 48. And they might add one more to say like it's 6. So I've seen different kids, but I will definitely say that knowing your times tables is really helpful for being able to do this math. But if you don't know them, you could just do different types of counting. It would just take longer. And being that this is a time-consuming problem, luckily this is the last problem in this day one, you can spend the time to do it. But if it happens earlier in the test, you can just skip over it and just come back to it if you don't know your fact families. And then you can just do some counting with circles and stars to get to that number. All right, hit pause and we'll get to the next set of multiple choice problems from day 2. For the New York State test, there are 5 more multiple choice problems. There are 25 on day 1 and there are 5 more on day 2. And in this video, I'm going to do all the multiple choice problems in one video, and in the next video, we'll do the constructed response. So let's get into these last 5. All right, let's start with 26 and 27. The answers are B and D. For the first one, we want to know which one has been divided so that each has an area of 1/4. So that means which of these, when I cut them up, they have the same area. And you can think of it like when you had to share things with a sibling or a cousin, how you want if there were 4 of you and you had to break something up into 4 equal pieces, you would really, really want to make sure they were equal. So when I look at this first one, I wouldn't want this first one because this piece is really small and this piece is big. So I know that can't be equal. The other one that jumps out pretty easily is C, where you can clearly see smaller pieces and bigger pieces. So even though there are 4 pieces, they're not equal. So now we have B and C. B, definitely, they all look like they're the same size, it's cut up. But D is meant to be tricky. because they do kind of look the same size. Like these three are exactly the same size, but I can't say that this is the same as this. That's where it gets a little tricky. Look, like, so this one side here, look how long it is. So if I were to draw it on the other side, it would be this big compared to the other. Like, that's a much bigger piece than the other two. All right, and sometimes when they give you these type of fraction problems, there's two that jump out as definitely not equal pieces, and one that tends to look a little tricky. Let's look at the next one, which is a pattern problem. I like pattern problems a lot. We have the pattern 1, 5, 9, and 13. What are the next three numbers in the pattern? Well, the first thing we have to do is discover the pattern. So I'm going to make it just a little bigger just so we can see it. 1, 5, 9, and 13. And my numbers are increasing, meaning they're getting bigger as I keep adding on to them. So from 1 to 5, I'm adding 4. I get 4 more. And then from 5 to 9, I have 4 more. And from 9 to 13, I also have 4 more. So this is what makes it a pattern, is that I'm repeatedly adding 4. That's the rule here. So if I were to continue in this pattern, and let's say I have 13, so I know I'm going to first add 13 plus 4, and 13 plus 4 is 17. And then the next number would be 17 plus 4. 7 plus 4 is 11, so this is 21. And if I would do the next one after that, 21 plus 4, 21 plus 4 would give me 25. So now I'm just looking to see, where do I see this pattern, the sequence, 17, 21, and 25, and I see it here. So as soon as I got that first 17, I knew I could have just crossed these two out. And then I had to keep going with the other ones to check. All right, hit pause and jot this down into your notes. Let's look at 28 and 29. The answers for here are C and A. So if you have them, keep it going to the next chapter. If not, stay right here. All right, for the first one, 28, we see a bathroom has an area of 36 square feet. So I know there will be 36 squares in that floor picture. So which figure could be the bathroom? Well, so I'm going to, luckily two of them, these two here, are rectangles, so I can just use some multiplication. So here I have 3 times what number? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I have 3 groups of 9, or 27. So that's not 36, so I can cross that one out. And on this side I have 4. 1, 2, 3, 4, 5, 6, 7, 8. 8 groups of 4. Which is 32, and that's not 36, which is what I'm looking for. All right, so the next ones are irregular, so I can do different things. One, I could just honestly count which ones have 36, so I could just count them in as long as I don't make a mistake. That's fine. I'm also going to let me just highlight the square here and add it with the other piece, just so I have this. And here I have 3 groups of what number? 1, 2, 3, 4, 5, 6, 7, 8. So here I have 3 times 8, which is 24. And then I have 1, 2, 3, 4, 5. So I'm going to add 5 to that. And that's 29. That's not enough. So you saw that I just, instead of counting every square, which you can absolutely do, it just takes time, and luckily this test is untimed. But I'm using my multiplication skills to skip some of the counting, since I know I have some even rows here. I have an array. Same thing here with C. I have 3 groups of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 3 groups of 10, which is 30, plus 1, 2, 3, 4, 5, 6. And 30 plus 6 is 36. So we have this right. And this should be one of the ones that, even if it takes you a long time to count, you should be able to find the answer for, because we know that there should be 36 squares. Let's look at 29. It Cecilia is creating holes to plant seeds in her garden. She has 12 corn seeds and she has 15 bean seeds, and she'll plant all the seeds. Which set of equations can be used to find the total number of holes, H, if she puts exactly 3 seeds of the same type in every hole? So this is one where I kind of have to think about what's happening. And I'm going to start with like the corn seed. So that means every time she puts a hole, she's going to put 3 seeds inside. So like I'm going to have 3 corn seeds. And then I'm going to have another 3 corn seeds, another 3 corn seeds, and another 3 corn seeds. So that's what's happening in the problem. So another way I can do this is I could have said, well, how many 3s, how many holes can I have? If I have 12 and I'm putting 3 in every hole is equal share, 12 divided by 3 is equal to 4. And now I know the same thing is going to happen with the bean seeds. I have 15 of them, and I'm going to put 3 in every single hole. So 15 divided by 3 is 5. So how many holes am I going to have? Well, I have 4 corn seeds and 5 bean seeds. So I know that I'm going to have altogether 9 holes. And this matches my answer for A. And I had to really think about this problem a lot because I was like, wait a minute. So are we mixing them up? What's happening? I had to kind of draw it out to think about it to see what would happen to figure out the total number of holes. For B is very close. The first 2 steps are the same, but I'm not multiplying the number of holes together. It's not going to give me the total number of holes. So that's where B gets tricky. It looks very much like the answer, but it's not the same. And with C and D, all you're doing is subtracting just one set for each one, so that's not right. And the second one, the same thing, you're subtracting one set, and that's not right either. All right, let's look at the last multiple choice question on day 2. Which fractions are equivalent? The answer for this one is C. So let's see how we get there, and I'm glad this is the last problem for today because it is a little bit of a doozy problem. It's spicy. Spicy isn't bad, it just means it's going to be a little bit more challenging than usual. It's going to take a little bit more time. All right, I'm going to show you my strategy for figuring out if 2 fractions are equivalent when they have different denominators. So I'm going to split up my paper to A, B, C, and D so I can look at each set and do my comparison work. So the first one I have 2/3 and I have 3/6. And what I'm going to do is I want my denominators to be the same. I want them to be the same. And some kids can very easily just see like, well, 3 and 6, if 3s, I can count by 3s and make 6. There are some kids who just see it. And if you're one of those kids, awesome. I'm glad you see it very quickly. You know your multiples, you know your fact families. But there are some numbers where it's not so easy to see it, so I want to give everyone a strategy for this. And what this strategy is going to do is I'm going to multiply by the opposite denominator as 1. So this is called a property of 1. The name is not that important, but I'm going to multiply each of these fractions by the denominator of the other. So you see this 3? I'm going to multiply by 3/3. You see this 6? I'm going to multiply by 6/6. Why? Because this fraction, 6/6, is like multiplying it by 1. And 3/3 is like multiplying it by 1. But the reason I want the opposite number is because it's going to make my denominators the same. Watch what I mean. 6 times 2 is 12. And now I'm going to multiply my denominators. 6 times 3 is 18. 3 times 3 is 9. That's all I did. The tops. And I did the bottom. 6 times 3 is 18. Now I can compare them. Are they the same size? No. 12 out of 18 is much bigger than 9 out of 18 because I know they're the same size now. So, nope. Now that my denominators are the same, I'm just comparing my numerators. This is not true. I'll do the same thing for B. 1/4 and 4/8. Remember, I'm going to multiply by the opposite denominator and turn it into a fraction of 1. So on the right, I'm multiplying by 4 over 4, and on the left, I'm multiplying by 8 over 8. So multiply the tops first, my numerators, and then my denominators. 8 times 1 is 8. 8 times 4 is 32. 4 times 4 is 16. 8 times 4 is 32. Now they're the same side. I can compare the numerators, and this is not true. 8 is smaller than 16. So let's look at C. 2/4 and 3/6. You know I'm going to multiply again by the opposite denominator. That's all I did. And I'm doing this because I want my numerators, that I can compare them when my denominators are the same. So 6 times 2 is 12 over 24. 3 times 4 is 12 over 24. These two are equal to each other. So I can compare them. Now, the reason, again, in the beginning, remember I said how some fractions you can look at them and you can just figure out what fraction makes them the same. Sometimes you can't, like there's some kids who look at 6 and 4 and they may not see what a common denominator is. And there are many common denominators you can use. So I know some kids can also use another strategy that I'll show you in a second to compare. I just find it to be a lot. As a matter of fact, I'll do it with D so you can see it with drawing. So let's say I have 1/12 and 2/8. I know some kids who you can go and you can make a table from both until you get a common denominator. And they just use skip counting. So I like to start with a smaller fraction first. So 2's, 2, 4, 6, 8. That's easy. Now I have a common denominator. I have 8 and 8. And then 1, 2, 3, 4. And then they can just compare. 4 8s is not the same as 2 8s. So this does work as well. If you want it as another strategy, you could just use the skip counting strategy. Different ways to do the same thing, but I wanted to make sure that everyone had a way of finding a common denominator so you can compare fractions. All right, so you can do a table like this until you find the same denominator, or you can use this property where you can find the same denominator. What I like about this one is that I'm just multiplying one time and I instantly get an answer, where sometimes with a table I may have to I have to maybe skip count a lot until I find the same denominator. Well, that's it for, this was the very last multiple choice problem. Remember, there are 25 in the first day and there are 5 more in the second day. So I hope this was great practice for you. Even though it's multiple choice and you may be doing it on a computer, remember that you want to use your scrap paper and really make your thinking visible, put it down on paper and slow yourself down. There's no real advantage to just rushing through. So take your time, really know your thinking, and if you're not sure what to do, you can always skip over a question and come back. That's it for today's lesson. I hope you found it really helpful for the state test, and I'll see you in the next one on constructive response questions. Bye.